What is a neural network? It can partially be considered as a universal function approximator. Just say you have the function f of x is equal to x cubed. So the way I like to visualize it is you put in x, the result pops out over here as f of x. But what a neural net does is it figures out what goes on the other side of the equal sign. So that's a simplification. Another simplification of neural net stuff is the ReLU, or Rectified Linear Unit Activation function. And all it is the max, or the maximum, of 0 or whatever comes into it. Just say if -2 comes in, what's the maximum? -2 or 0? Well, 0 is higher than -2, so 0 comes out. So what if 4 comes in? Well, 4 is higher than 0, so 4 comes out. So that's what the rectified linear unit activation function is. And also, you might have heard of categorical cross-entropy. And with classification in neural networks, basically it's just a negative natural log of the target class. The logits, that's the output of the neural network, the raw output, pass them through a softmax function, which is just e to the x divided by the sum of all the e to the x's. And then the target class for that is what goes into the raw data, the raw outputs of that target class. That specific number goes into the negative natural log, and that gives you the categorical cross-entropy loss. So those are some complicated sounding things that are actually relatively simple in neural networks. And there's other stuff too, such as a transformer is like ChatGPT, the T. From my understanding of it, it's a sort of a version of a recurrent neural network. LSTM, or long short-term memory neural network, is a version of a recurrent neural network. So all three of those are related quite a bit, and they have to do with sequences and partially like remembering the previous data and so on. So there's that paper, Attention is All You Need, that introduced the transformer, like the T in ChatGPT. And this is what it looks like. And there's that softmax I talked about earlier. And this is just a linear layer. This is adding something and normalizing it. I'm not sure all the details of here so far. It's a feed-forward neural network, the typical ones you see with the dots and the lines connected to other dots, and the activation functions, such as the super complicated ReLU, which is not complicated, and the neural net learns and it predicts the next output. Like if you said the United States of, probabilistically, a lot of people would say America is the next word that follows. So that's what a transformer like ChatGPT does, is it takes a sequence of words like the United States of and said, likely, based on the data I've been trained on, what's the most likely word that comes out? It's America. So the positional encoding at the bottom, it just says it's basically assign a number or something like that to each word so that you know what order they go in. Because if you said the America of States United, that's different than saying the United States of America. So, and the output embedding, or the embedding, is where you take the things that you like the words and the relations to other words and so on, and put them in a vector space. Picture a 3D vector space, like three blue, one brown YouTube videos where he talks about learned language models or stuff like ChatGPT and so on. It shows arrows representing the direction and how long the arrows are, which represents the magnitude, and how they're related to one another. Like an example he gives is king and queen are related, or a certain distance from each other in certain directions. In the sort of the same way that man and woman are related to one another. So that was pretty interesting the way he described it. And from my understanding, when you backprop through a transformer, um, part of what's happening is certain things is just addition, and addition is, as Andrej Karpathy calls it, a gradient router. So if you have the derivative of a plus, in other words, it's 1. And so if you multiply or chain together anything with 1, it just makes that thing. So when you just say you have a gradient of 0.5, and then you're chaining it together, the chain rule, it just means multiply the derivatives together, each of the local derivatives, to get the global derivative. So if the derivative is 0.5 and you multiply it with 1, it's 0.5. And you multiply that with 1, it's still 0.5. And so that's part of an advantage of a transformer, is certain parts of, I don't know if it's all of, but certain parts of the transformer, the derivative is just 1 over and over. So, and one advantage a transformer has over a recurrent neural network is that there's something called a vanishing gradient problem, which, from my understanding, means that if you have a long sequence of words, and like if you're asking a question in a lot of detail or whatever, then some of those first words get faded out kind of in the recurrent neural network. But with a transformer, they don't get faded out as much, or any, because the recurrent neural network, it can go to each of the words sort of separately instead of just letting them pile up. It can go to each of the words separately and see how the word itself is related to the previous words. And so that's a general overview of some stuff that I've been learning lately. And if you have any questions or stuff you'd like to see, let me know. And thanks for watching, and please click like and subscribe. Bye.